I'm going to have you do naming polynomials by degree. So degree is the highest exponent except on a monomial. And remember, monomial means there's only one term. So I'll show you what I mean. For right now, I'm going to ignore monomials and then I'll come back to them. So highest degree, if I have something like this, the highest degree is 2. If I have something like this is not in standard form, but I can still see what the highest degree is. The highest degree is 3. And remember, when the exponent's on a constant, it doesn't count. So this is on a constant, so that degree doesn't count. The highest degree here has to be on a variable. The highest degree is 4. So I'm going to make a table to name it by degree. And I'm going to put name by degree. Oh, sorry. I'm not actually going to do that. I'm going to say degree. And then I'm going to say name by degree. So when we're talking about degree, again, ignore monomials for right now. I'll show you something. Monomials are slightly different. The lowest degree we can have is 0. And we can have something that's a degree of 0. And I'll show you what that looks like. And the name for that is a constant. And I'll show you examples of all of these. Then the next one is a degree of 1, which is called a linear. Then a degree of 2, which is called quadratic. Degree of 3, which is called cubic. Degree of 4, which is called quartic. And degree of 5, which is called quintic. Degree of 6, which is called sixth degree. 7, seventh degree, 8, eighth degree, etc., etc. So we only go up to 5 with a specific name. Everything else is just that the degree. The biggest mistake that people make is making a mistake with these, quartic and quintic. I like to think of quartic, it sounds like a quarter. There's 4 quarters in a dollar, in a basketball game, in a football game, etc. So 4 quarters, quartic, 4 quarters. So that helps me remember that it means 4. And then quintic, for me that kind of sounds like a quince, which I know is 15, but it helps me remember that it's 5. So I'm going to show you what each of these look like. If I have something like this, there's no variable, that's a degree of 0. So that's going to be called a constant. And a constant just means that it's a number. If I have something like this, remember that the x has an exponent of 1. So it has an exponent of 1, that's a degree of 1. And that's a linear. And a linear can also look like this, which you guys used to graph these in Algebra 1. And you said they're linear equations. I have a y-intercept of 7 and a slope of 4, linear equation. Okay? If it looks like this, this has a degree of 2, so that's a quadratic. But a quadratic could also look like this. It doesn't have to be a trinomial, it can be a monomial and still have a degree of 2. If it looks like this, that has a degree of 3, so that's cubic. If it looks like this, has a degree of 4, so that's quartic. If it looks like this, degree of 5, so that's quintic. If it looks like this, that's a degree of 6, so I call that a 6th degree. Now I told you monomials are special, and the reason that monomials are special is because when I have a monomial, I add, oh, this is for monomials only. Only monomials, okay? Add exponents of variables to get the degree. So what I mean by that is if I have something like this is a monomial because there's no addition or subtraction to separate it out, so this is one term. This variable has an exponent of 2. This variable has an exponent of 2. I add those together. It's 4, so it's 4th degree, which means this is quintic. Quartic, sorry. Come on, Latimer. Quartic. If I have something like this x actually has an exponent of 1, so I'm going to do 1 plus 3. Degree of 4, so that's also quartic. So that's only with monomials.